All right, 3.15. So this is the last section of Unit 3. We've made it. This is the last one that is tested on your AP exam. So we're just going to get right into this, right? We're going to get it done. So we are looking at rates of change in polar functions. So first thing we have is we have different set of intervals where I'm going to go ahead and I'm going to figure out whether they're positive and increasing, right? So in the first one, I have from 0 to pi over 6, which is going to kind of be this little section right here. So from 0 to pi over 6, right? There's my other part. Well, I am positive and I am increasing, right? Then I'm going to look at pi over 6 to pi over 3, which is going to be my next little bit right over here, right? And so that's going to be this segment over here. Well, that's going to be positive, but it is going to be decreasing. So it's on the positive side, but it is going now down in my function, right? So that's what's happening over here. Here's my turning point. I've switched from increasing down to decreasing. My next bit is from pi over 3 to pi over 2, which is going to be on my section here, right around here. So it looks a little bit different because it looks like it's going towards the 3 pi over 2, but it is essentially still on the same area. So what's going to happen is this is going to be negative, because it's now in the negative section, and decreasing. And then my last segment is going to go from pi over 2 to 2 pi comma 3. So it's going in this direction. So it is now going to be negative, but it is going to be increasing. Okay, so now if we're talking about distance from the pole, when f of theta is increasing and r is positive, we are increasing, and I'm going to be farther away. When r is positive and I'm decreasing, I'm decreasing, meaning I'm actually going to be closer. When r is negative and I'm decreasing, that means that I am now going to be closer. And when I am negative and decreasing, I am increasing here. I think I definitely spelled increasing wrong. It's in a long unit. Increasing, meaning I am going farther away. Okay? So now I'm going to look at the chart, right? I have here an example number 2. There's all my wonderful information spit out. So the first thing says, describe the behavior of the function on the interval from 0 to pi over 2. So from 0 to pi over 2, so this whole bit of information happening right here. Well, what is happening? R is positive, and it's also increasing, right? Which means, so if I'm positive and increasing, well, I'm going to be, my distance from the pole is also increasing, I'm going further away, right? Now let's see, from pi over 2 to pi, okay? Well, my r is still positive, but now it is decreasing. So if it's positive and decreasing, well then the distance from the pole is decreasing, meaning that it is going closer. Now they're saying, what is the average rate of change on the interval? Well, average rate of change, slope, right? That's all it is. I'm using these two values right here. So I have 4.33 minus 2.5 over pi over 3 minus pi over 6. Well, when I go ahead and do that, I'm going to get that this top part is 1.83 over, now I have to change this, so I'm going to work this out on the side, right? Pi over 3 minus, pi over 6, not pi over 2, minus pi over 6. Well, I need to change this to be pi over 6. So this means that I had to multiply by 2, so it's going to be 2 pi over 6, leaving me with just a pi over 6, right? So then what's going to happen is I'm actually going to multiply these. Remember, it's going to be 1.83 times the reciprocal, which is 6 over pi, which gives me 10.98 over pi. And then when I go ahead and calculate that, I get that it is about 3.495. The slope is the slope, no matter what it is, right? So that means the radius is going to change the units. Radius changes per radian, so it's units per radian. Units per radian. Okay, and then it's saying estimate the value of pi over 4. Right, so I don't have pi over 4. So what I have to do is I have to use my y minus y1 equals mx minus x1. So this is actually the point slope formula. So if you remember that from geometry a long time ago, I don't think they taught it last year. If you were, you wouldn't have been in geometry last year. But everyone should know the point slope formula, right? I'm going to pick two different points. Well, I'm going to go ahead and say, well, I'm going to use pi over 6. I think pi over 6 is close enough to pi over 4. So I'm just going to say y minus 2.5 equals my slope, which is 3.495, and then x minus pi over 6, right? Then I'm going to go ahead and just calculate it. So that means I'm going to have y minus 2.5 equals, I distribute, so I get 3.495x minus 1.829, almost back to the original, right? That makes sense because, you know, that's what I multiplied by. Then I'm going to go ahead and add 2.5. And I get that I'm going to have to move over here. Y is equal to 3.495x plus 0.67. So now I have my equation of my function. So I'm just going to go ahead and plug in pi over 4. So y equals 3.495 times pi over 4 plus 0.67. I'm running out of room, so I'm just going to kind of put this all in my calculator and get my final answer, which is going to be that it's going to be about 3.414. And that makes sense, right? Because pi over 4 lies in between pi over 6 and pi over 3. So it makes sense to have a value that's somewhere in the middle of them. Okay, now I'm going to let you solve example 3, and we will do that together in our meeting tomorrow, in our Zoom meeting tomorrow. We will go over this example together. before we do our practice problem. There are a lot of parts to it, so I do want to make sure that we go through all of them. I do think it's also going to be really good. And that'll be the end of 3.15. So please work out this problem before tomorrow. And happy studying. You will all do wonderfully on Monday.